Okay, this is section 7.3, number 39. And number 39, it says the base of a solid is the region between the curve y equals 2 times the square root of sine of x and the interval 0 to pi on the x-axis. That's just the x-axis. And the cross-sections perpendicular to the x-axis are, and letter A, equilateral triangles with the bases running from the x-axis to the curve as shown in the figure. So basically what we have are these are equilateral triangles, and the actual length of each of the sides are all the same, so the length of each side will be just given by the value y equals 2 sine of x. You can think of it as top curve minus bottom curve, the bottom curve being y equals 0. And I remember we talked about this in class before, that the area of an equilateral triangle is given by just the square root of 3 over 4 times the side squared. So basically this is our side, so all we have to do is put 2 times the square root of sine of x into the side. And so we have area equals the square root of 3 over 4 times 2 times the square root of sine x squared. If we square this, we get 4. And these 4's cancel, and then we get the square root of sine x squared is just sine x. So that's our area. Let me put this into our integral over here. That's going to be volume equals the integral, and we're going to go from 0 to pi of my area as a function of x times dx, or dx. And that's going to be the area over here, which was square root of 3 times the sine of x dx. And then what I can do is I can take the square root of 3 out. So I've got the integral from 0 to pi of sine of x dx, and that's just the antiderivative of that is just negative cosine of x evaluated from 0 to pi. And remember, I still have the square root of 3 out front. And negative, and the cosine of pi is negative 1, so I've got negative 1 minus, and this is from the f of b minus f of a, this is the negative there. And the cosine of 0 is 1, but I've got negative that, so I got another negative 1. So this ends up being 1 plus 1 is 2, and times the square root of 3, and that's your volume. Now the b part, they're just squares, so that's even a little bit easier. And remember, the area of the square is just side squared. And again, that side is going to be given by 2 times the square root of sine of x. So area of the square equals 2 times the square root of sine of x squared. And when I square that, I get 4, and I get the sine of x. So that's my area as a function of x. So I put this in the integral over here. And I get volume equals, sorry about that. Okay, so volume equals the area here. 4 sine of x, I can bring the 4 out in front, so I'm going to take the integral from 0 to pi of the sine of x, which is very similar to the a part. That's going to be the antiderivative of the sine of x is negative cosine of x. And again, when I evaluate that from 0 to pi, I get the same thing as I got above in part A, 2, but I just have a 4 out in front, so 4 times 2 is 8, so that's your volume. So those are both pretty easy, and they're very similar.